Hi, welcome back. Keypads represent an intuitive way for people to provide input to gadgets and computers. You'll find them in elevators, microwave ovens, TV remote controls, phones, and countless other machines that we interact with daily. Sooner or later, you'll need to provide alphanumerical input to your gadgets via a keypad, and in this lecture, I'll show you how. Keypads come in a variety of sizes and styles. Some are using push buttons, others use touch buttons. Some are organized in 3 rows with 3 columns each, others with 3 rows and 4 columns, and others with 4 rows and 4 columns. Regardless of all that, most keypads you're likely to use in your projects consist of an array or matrix of buttons and wiring that connects them to connectors so that when a button is pressed, a circuit closes. A device that reads the keypad is responsible for figuring out which key was pressed by monitoring the state of these circuits. Have a look at this diagram. If you press key 3, then a circuit that connects column 3 and row 1 is created. Current will flow through the circuit and some voltage differential will be generated. The device that receives input from the keypad will somehow detect this differential and determine that key 3 was pressed. In this lecture, I will demonstrate how to connect a common 4x4 keypad that contains the numbers, letters A, B, C, and D, a star, and a hash. I will do it in 2 ways. First, I'll use the keypad library that comes with the Arduino IDE in a sketch that reads the keypad, while the keypad is connected in parallel, which means that all column and row wires from the keypad are connected to 8 of the Arduino's digital pins. Because this way of connecting the keypad is extremely wasteful of our precious digital pins, of which the Arduino only has 13, in Demo 2 I will show you how to hack together a solution that allows for a connection that uses a single signal pin. In the first demo, we'll plug a 4x4 matrix keypad directly into the Arduino and configure the sketch so that the correct symbol appears when a button is pressed. The ugly schematic here represents a keypad with 4 rows and 4 columns. It connects to the outside world with 8 wires, 4 for the rows and 4 for the columns, on which the keys are placed. The blue wires connect the rows to Arduino digital pins 2, 3, 4, and 5, and the yellow wires connect the columns to Arduino pins 6, 7, 8, and 9. You can see that this way of connecting a single peripheral device is easy but very wasteful. There's not many pins left for sensors or other peripherals like LCD screens or Ethernet adapters. So we'll just play along for now and understand how the keypad works with the Arduino at its simplest configuration. And then, in Demo 2, we'll have a look at a more real-life configuration. Once the connections are done, the circuit depends solely on the software side to figure out which button has been pressed and to display the right symbol in the monitor.